Hello everyone, let's continue our discussions on hydraulic components. In the previous section we had discussed the reservoir, the hydraulic tank, the hydraulic pump and the hydraulic motor. Let's move on and look at some of the other components of a hydraulic system. Today we'll be talking about the control valve and also the hydraulic cylinders and actuators. And we'll also have a look at how all these components come together and function as an efficient hydraulic unit. The control valve basically controls oil pressure, the direction of flow and the volume of the flow in the hydraulic system. So it plays a very critical part in these three functions. And there are three types of valves. The pressure control valve, which operates under a simple principle where you have a poppet which is spring loaded at a certain pressure, and this is the closed condition, and when this pressure is reached, it opens out and allows the pressure to be relieved. Then you have the directional control valve where the oil flows are directed into various actuators, etc., and that is a function of the directional control valve. The volume control valve, on the other hand, controls the extent of discharge or the volume of discharge of hydraulic liquid. There are two types again of relief valves. One which is direct acting. As you can see, there is a poppet setting again, and at a certain pressure it opens up, and it's used in places where the volume of flow is small and for less frequent operations. In this system of pilot operated relief valve, you can see that there is a line going into the pilot line, and that gets actuated at a certain pressure again, which in turn relieves the pressure from the main control valve, and the discharge happens back to the reservoir at that set pressure. So this is used in places where larger volumes of oil are used, and this is essentially how the pilot circuit is provided to operate the relief valve instead of a mechanical setting. So the cracking pressure is the pressure at which the relief valve first begins to open. So as you can see, it is at a slightly lower pressure setting. If you look at the full flow pressure, this is the pressure at which the relief valve passes its full quantity of oil. So you have cracking pressure, which is the starting point, and then the full flow pressure. So looking at the hydraulic cylinder, it is very similar in functionality to the muscles that move the arm. So the cylinder in effect moves the arm or the attachment of the equipment. So taking an example here of the hydraulic cylinder, you can see the cylinder here operating the arm of this wheel loader. Similarly, there is another cylinder which is operating the bucket of this hydraulic cylinder. So let's look at the operation of a hydraulic cylinder. Oil is supplied to the pump. The pump pushes the oil out. The oil goes to the control valve, and two pipes from the control valve are connected to the cylinder. So you can see the oil flow happening, going back into the cylinder and pushing the piston up. So this is the oil from the control valve which is directed into the piston. Oil at the piston top runs back to the reservoir via the control valve. And when the pressure exceeds a set amount, a relief valve opens, which you can see here, and allows oil to flow back to the reservoir. So in a sense, you have all these units combining to create a hydraulic system that operates this machine, which is a hydraulic excavator. A reservoir, a pump, control valve, cylinder, connecting lines and a relief valve all together make up this hydraulic system, which is functional in this hydraulic excavator. It's equally applicable in other equipment like wheel loaders or backhoe loaders, etc. Now let's look at the process of conversion of or transfer of energy. So in the engine, the mechanical energy is created, and then in the pump, this mechanical energy is converted back to hydraulic energy. And then at the actuator level, the hydraulic energy is converted back to mechanical energy. So this is the process of transfer of energy. So let's summarize this by looking at a simple circuit of a hydraulic system where all the components that we just discussed fall in place. So you have a pump which pushes the oil out, and the connecting lines which take the hydraulic oil to different parts of the hydraulic system. The control valve controls the oil flow and the flow direction. And from the control valve, you have flows happening into the swing motor, travel motor, and the other actuators like the bucket cylinder, the arm cylinder, and the boom cylinder. So this, in short, is the basic hydraulic circuit, which is almost universally applied in various construction equipment. And we would be in future sessions talking more in detail about more complex hydraulic systems, more efficient, more sophisticated hydraulic systems, how they can be created by changing the components and adding different levels of technology into each one of those. Thank you.